Good morning, everyone. Thank you for joining us here for our Cosmic Conversations. My name is Josh Roberts. I'm part of the Morrison Planetarium team at the California Academy of Sciences, and it is my privilege to get a chance to participate in your house for a very cool science presentation called Cosmic Conversations. We try and bring in a science specialist from our wide family and friends from the Morrison Planetarium to give us some content about their expertise. And today we'll be hearing from Ryan Wyatt, our Senior Director at Morrison Planetarium. Here's Ryan.
Hello.
As well as Bárbara Rojas-Ayala, who is our narrator for our upcoming planetarium show, Big Astronomy. Hi, Barbara.
Hi. How are you?
So in Big Astronomy, we talk about a lot of really cool stuff happening in Chile and the telescopes that are there. Ryan or Barbara, is there anything you'd like to share?
Sure. Well, first of all, thank you so much, Abs, for joining us from Chile. Only a couple hours time difference, luckily, but really glad to have you here to talk a little bit about some of the things that we talked about in the planetarium show, which will be opening in September, either live in planetariums, or we're looking at ways to stream it, since a lot of planetariums may not even be open in September. But then also talk a little bit about your personal experience getting into astronomy and some of the things that you study. So thanks for your time and thanks for joining us.
No, thank you for the invitation. It's really a pleasure, to be here and be able to talk about astronomy and my country.
Very cool. Well, I think one of the cool aspects of the show is talking about why Chile is such an important place for astronomy. And I think we had some kind of cool visualizations of wind and weather that contribute to that.
Yeah.
So hopefully you folks can see a big blue map with some moving green stuff. This is a map made available from the nullschool.net, if you folks want to check it out, aggregating U.S. National Weather Service data along with NASA data. That's actually showing us the temperature of air at the surface of planet Earth. And Barbara, maybe you can correct me. I tried to put that green spot as close to where the ALMA array would be as possible, but I will admit, as a product of the California public school system, my geography is not great. So
no, that's perfect. Yeah, that's fine.
So if you folks have a chance to look at your screen, you should see these moving lines, each one indicating sort of a vector for wind and how fast it's traveling. You can play around with this. Now, I'm not seeing too much activity right where that green cursor is compared to the areas around it. Why is having such a low wind speed an important thing for ALMA?
Well, one of the things that we really want as astronomers in the optical and in the infrared and in the sub-millimeter wavelengths is to have a very stable atmosphere, right? All the light that comes from, planets, stars, galaxies has to pass through our atmosphere, and our atmosphere is full with atoms, etc. So, especially molecules. So the desert, the Atacama Desert in my country, it's the driest desert on Earth. So there is very little water in the atmosphere, which is great because then photons can pass through the atmosphere without being, intercepted or captured by these molecules. And also you want a stable atmosphere, right? You don't want winds. You don't want anything that basically can perturb or, affect the image that you can get of whatever you're observing.
So if folks take a look now, we've got this change of blue and yellow. This is showing us the relative humidity, the amount of moisture that's contained in the air. You look right around ALMA, and the Atacama is very, very yellow. That's telling us it's really dry. And for contrast, you can look down where we heard it was raining today in Santiago.
Yeah, even south. Yeah.
And a lot of other spots on our globe are this pale blue, indicating that they're experiencing extreme rainfall, including, it looks like, around the Amazon. But I suppose that shouldn't be surprising to anybody. So
yeah.
That said, I do remember we got caught with our production team in a snowstorm at Alma. So there is bad weather there sometimes.
Sometimes during the summer, which is called, the Bolivian winter. You have that. You have to remember that this is really high altitude stuff, right? We're talking about the Andes, and indeed during the summer they do suffer of storms, and usually at that altitude it is basically snow. So that's something that does happen in ALMA. It doesn't happen in other observatories. For example, at the CTIO, that doesn't happen. It will happen probably in winter, but not during the summer. So it depends on, the month of the year and where are you observing, like what are the conditions that you can find.
Well, and you mentioned CTIO, so that's the Cerro Tololo Inter-American Observatory.
Yes.
And that's kind of where the sort of story of astronomy started in certain ways in Chile, right?
Yes. So the astronomy in Chile started basically in the late 1800s, where people wanted to build a national observatory. In the mid 20th century, the director of the National Observatory of Astronomy here in Chile had a huge role in trying to convince scientists in the States and in Europe that Chile had the perfect, weather conditions and geographical conditions to do astronomy, but also that there was a government that was really into, inviting them to put telescopes here, and that we have the infrastructure, to do it. We had basically the technology. This is a really old picture, though, right?
I mean, it looks like it's from the 19th century, but it's actually from like 1963, I think.
Exactly. This one, I think it comes from the CTIO website. You can go and try to find them. And you can see all of these people in donkeys. So this was a group of people that came from AURA, the Association of Universities for Research in Astronomy, and people that were from Europe, from the ESO, from the European Southern Observatories, that also wanted to install some telescopes or observatories in the Southern Hemisphere. And you can see them here testing basically a site that it's very close to where, Cerro Tololo is now. And in order to get there, they had to, use mules or donkeys or horses.
I thought the road there now was rocky, but it's not the good comparison.
It's true. You cannot just go with any car there. It's still... It is still, like you said, it is kind of rocky. It's true. Yeah.
But then we fast forward a few years, and they're actually, I think this is building the foundation of the 4-meter telescope. Yes,
the Blanco Telescope. Indeed, the dome, it's actually quite big compared to, more modern 4-meter telescopes. There is another 4.1-meter telescope in a hill close to CTIO, the SOAR telescope. And when you compare the domes, the dome of the new one, it's very tiny. Mm-hmm. And this one was very large just because of the way that the telescope was built and how it's supposed to move. It's very similar to the dome that you have in Kick Peak, for example.
And then, I think we'll see pictures of the dome later, but there's a lot of infrastructure in the dome too. I mean, it's like 7 stories tall just before you even get to the telescope.
Yeah, because everything was happening in that building now. I mean, at that time, right? Now, the more modern ones, basically, they have the things separately, right? The machine shop and everything, it's in another building and not necessarily where the telescope is.
And then, maybe you can tell us a little about these other images.
Yeah, I think this is when basically they inaugurated the road to go up to CTIO. So they're cutting there this thing, right? I cannot remember the name in English. The ribbon. Thank you.
It looks like they've got some waiters in the background, so at least they're not.
Yeah, probably they have some pisco sours there.
And then actually talking about a blast from the past, looking through an actual eyepiece of a telescope, that's also something that doesn't happen much anymore.
Yeah, but however, there are still, people that believe that this is the way that astronomy is done. And this is a question that actually a lot of people ask about, like, how are we observing or what we're looking and how we do it. This is President Frey when it was really inaugurated, the CTIO. You can see also everybody, it's very, well dressed with ties and everything. I don't think I have ever seen an astronomer like that in the mountains, ever observing like that.
Exactly. Well, then actually CTIO is also where you got your personal start in astronomy. So I'm going to do a little switcheroo here and maybe give you a different blast from the past.
Yeah. From the early 2000s, when I was an undergrad. Yeah. My first experience in an observatory was actually at the CTIO. I was selected as one of the students, kind of an REU student, the REU program, the research for undergraduates. And it was fun. And I think it was when I really realized what astronomers, observational astronomers, can do. And actually, it got me really motivated to continue a PhD. At the time, I was doing my undergrad at Universidad de Chile. And it was great to have young researchers there that were very into, encourage us to follow a career in science. And most of them were very encouraging me to just continue and say, hey, why don't you go and do a PhD in the States? You can apply there. You can get a fellowship. You can get, a stipend. And it was great.
And this is how most of astronomy is done today now, looking at computer monitors rather than through the eyepiece.
Exactly. It's not like what we're seeing there. We use computers. Usually, when I give talks, outreach talks, I try to find a picture where people can see what we really do when we're there. Even now, in more modern and bigger telescopes, you're not alone. You usually have somebody that has the preparation to basically control the whole telescope, and usually you're just in charge of the instrument that you're using.
Right.
And it's full with the screens where you can see the weather, you can see a lot of stuff.
And this is actually in one of the control rooms for the telescope, correct?
Yes. Let me see if I cannot see the picture. I think we're still seeing the one of the president.
Oh, sorry. I thought I switched it up. So we haven't been looking at pictures of you at all. Sorry,
no, we haven't.
I'm flying a little blind. I'm using a different suite of technologies than I have in the past. So I'm so sorry. Let me go back and give you a chance to talk about. Now, are you seeing the pictures of?
Yes.
Excellent. Very good.
So, for example, the picture that we see there, it's a picture of the 0.9 meter telescope, the observing room. So you can see that there are 4 people. I was terrified making a mistake while we're observing there, because I have this guy behind me. And basically we spent this was probably either my first day or my first week really observing. We were doing photometry. We were observing some cataclysmic variables for Linda, that it's right there. She was a fellow. She was a postdoc at ESO at the time. Now she still works at ESO. And I think at the end of that day, we were observing a globular cluster. And that was really fun, because I was able to see an image really of, how it looks and, the density of stars and everything. It was really fun. But I was terrified of making, a mistake.
Well, I think we have a happier picture of you over here.
Yeah, that was because it was a research experience. Each of the students that were involved, there had a specific project. We have our own mentor. And at that time, I was working with Spectra from Gemini. Gemini was recently inaugurated, Gemini South. And I was working with data of galaxies. And what we were trying to do was rotational curves of dwarf galaxies. That it was something that was not, done at the time. And I was able to actually measure differences, velocity differences, and see these rotation curves. It was fun. I enjoyed it a lot. It was very different from the things that I had worked as an undergrad. I work with the stars, so working with galaxies was a really good thing to realize if I like them or not.
Right, that's good.
And I continue with the stars. So I think I like the stars more. And there is a picture of all of the participants of the RUU via program of 2004. We are there. You cannot see it, but that's the kind of there is this stairs right next to the Blanco Telescope, the 4-meter telescope. Yeah, we're there inside the dome, and the telescope is behind us.
I'm trying to give a sense of some of these. Maybe what I'll do is, if you don't mind, switch to we actually have, it's not, unfortunately, like I said, we can't really go in the dome right now, but maybe we can share a little bit of the show with people. And I'm just going to show what amounts to a sort of an HD version of it.
Right.
But we can visit some of the so here we're just we're seeing where the show starts, which was actually the Gemini telescope that you mentioned earlier.
Yeah, it's an 8-meter telescope.
And actually, yeah, like you mentioned with the domes, the dome is actually kind of a similar size to something like the, in fact, a little bit lower than the CPA Blanco dome.
Yeah.
And here you can also get a sense of the beautiful Chilean skies, which I think it's hard to describe to anyone who hasn't been there. It's one of those things.
Yes, it is. I think when you go there and you get out of the dome right in the middle of the night, and you realize that, you can see the Milky Way like you have ever seen it if you live in a city, for example, where there is, a light pollution. You fall in love there. I really enjoy every single time that I go to, the mountains.
Actually, we had
so many stars.
Yeah, sorry, we had a question from online about native peoples of Chile and what their relationship was to astronomy, given the beautiful night sky.
Yes, so it's hard to know because especially the cultures that live in the northern part of Chile, where it's so dry and everything, they live by the coast. They did travel through the desert, but most of the cultures didn't have written stuff, right? But what we're able to see is that we see drawings or petroglyphs of things, that they have there. The cultures that are in the southern part of Chile, it's very rainy. Right. However, they did have a relationship with the sky and how, the earth was formed. One thing that is quite interesting, I was reading about this, is that they have the name for the first object that came out in the sky. We usually think of it as Venus. Mm-hmm. But they didn't make a distinction between if it was Venus or if it was some other star, for example. Oh. They used the same name for the object that will go up. Something that is interesting for the cultures in the north, and especially also the ones in Peru, Bolivia, and northern Chile, is that they have what they call these the dark constellations, something that is not common in the northern hemisphere. Here, since we are in the southern hemisphere, we're looking towards the center of the galaxy. So when you look at the Milky Way, there is a higher density of stars, and that allows us to see places in the Milky Way where there's basically no stars because it's dark, right? Actually, there are clouds or something.
If Josh can reshare the video, I think Josh is kind of the one behind the scenes here. This is actually an image of ALMA, but in the background you can see the Milky Way and some of those dark dust lanes. And
exactly. So those cultures, the ancient cultures, they will use those ones as constellations. They will call them names. There is one that is a llama, there is a fox, there is a frog, and there is this whole story about what is happening with those animals. There is a big llama and there is a little llama, and they're not made of, you know, bright stars like we usually think of constellations, but actually just these voids of, you know, light.
It's fascinating.
Yeah.
And yeah, and it's so interesting that, like, you know, we're so kind of in our connect the dots mode of thinking about constellations. It's really interesting to think about it, the sky in this very different way.
Yes.
Well, actually, since we're looking at ALMA, maybe it's a good time to just talk a little bit about what makes ALMA different. We were talking about its location in the Atacama Desert and how it's very high altitude and up in the northern part of Chile.
Yeah.
It's a very different kind of telescope from CTIO.
Yes. So this is a sub-millimeter, basically, observatory. For sub-millimeter observations, you really, really don't want any water or humidity in the atmosphere. So these things are really, really, really high in the altiplano. And they're huge, right? This is a huge group of antennas to do this sub-millimeter astronomy. And here you're showing one of this this kind of, yeah, basically that's what it is. They carry all of these different antennas to the sites, right? It's an interferometer, so you can play where you place the antennas in this in the altiplano, and you can create basically a larger telescope that will give you higher resolution. It will allow you to see better whatever you're trying to get at these sub-millimeter wavelengths.
But to do that, you actually have to physically move these giant dishes from one place to another, which is pretty extraordinary.
I think they built this machine, right? Just specifically for this type of antennas. There are 3 types of antennas. They're not all the same because ALMA, it's a collaborative project. So you have antennas that were designed in the US, you have antennas that were done in Europe, and ones that were done in Japan. But they all work together. And yeah, they had to build this thing just to move them around the site of ALMA to get the different configurations, right? When you have an interferometer like this one, you can offer the observer different configurations that will satisfy any conditions for the observation that they're trying to do. In the VLA, for example, in the States, they don't do this with this big trucks, but they have train lanes. So they move the antennas using the rails.
Well, maybe what we could do is, sorry, we're kind of zipping through the show here, but since we've actually gone through a lot of our time already, why don't we go ahead and maybe talk a little bit about one of the big future projects, which is the Vir and Rubin telescope that's being built not far from Gemini and CTIO.
Exactly. That's one of these kind of new ways of do astronomy. We are in this big data, right, era. And this telescope, it's really impressive because it's basically making movies of the sky every night. We're going to be able not only to see beautiful images of the sky, but we're going to be able to see them through time. So it's basically watching a movie of the sky. The idea of this telescope is basically look at anything that is variable, anything that changes with time. So we expect that a lot of new discoveries are going to happen, right? You can think of supernovae, for example, but also you can think of, systems that are variable just because the star, gets bigger or smaller, or because you're looking really at 2 objects that are, occulting each other. You can think of exoplanets, anything, that it's time variable. that the brightness changes, it's something that this is gonna capture for several years.
And we didn't get a chance to talk much about your research, but you look at M dwarfs, so some of these like smallest, plentiful but tiny stars in our galaxy, and they have like flares, and they show variation. Is LSST gonna or the Vera Rubin gonna contribute to some of the work you do as well?
Yes, exactly. The stars M dwarfs are very tiny. They're about the 70% of the stars of the galaxy, but some of them are extremely active. They have flaring events that are more energetic than anything that we have seen from the sun, for example. And this is something that, yes, we will be able to see those things because this telescope, it's large enough to actually see these very dim stars because they're so little, they're cooler, so they're dimmer, than a star like the sun. So it's a little bit more challenging, but this telescope has all what we need to basically see that activity for these stars.
Well, I'm sorry that we ran through our time so quickly, but I'm really thrilled that you could join us today. And I'll just mention that we were kind of breezing through some scenes from the show Big Astronomy, which is actually produced both in English and Spanish. So unfortunately, we're only doing this broadcast in English, but the show will appear in both English and Spanish. And for that, of course, we needed a very talented bilingual narrator. And I want to thank you again, Babs, for being the narrator for the show and bringing so much of your personality and your history with working in Chile to the show to be able to create a really, I think, authentic experience, because the show is about the people who really make these big observatories work. And it was so cool to be able to have an astronomer as narrator, and you in particular.
Yeah. No, I was so honored, to be part of this project. And I was a little bit terrified about doing it, both the English and the Spanish.
You had a second director for your Spanish version that was a little more demanding than I was, but I think that came out really well.
Yes. It's interesting that actually it was harder to do the Spanish version than the English version. Yeah. But no, I think it's a great project. I think it really shows the diversity that exists in astronomy. You don't need to be an astronomer just to be involved, in observatories and in astronomy. And I think the show really shows that.
Yeah. And it was great that you could share your personal story of how you got into astronomy. But behind all of the people that we talked to, everyone has their own story of how they came to work where they are, which is really just kind of wonderful to hear. And you'll hear some of those stories in the show, but I'll just do a little plug here, if you don't mind, for the bigastronomy.org website. We're going to be sharing a lot of the interviews and doing a lot of kind of live streaming like events like this, where we're talking to people as part of the bigastronomy.org site and on our YouTube and Facebook channels. So we actually kind of piloted it. You did us double duty. You were on our California Academy of Sciences Morrison Planetarium Facebook Live, but also on our Big Astronomy stream as well. So thanks again for joining us today.
No, thank you. Thank you for the invitation.
Cool. Well, I don't know if we have any other questions, but I don't see anything else pop up on the screen. Oh, actually, our question: will CTIO help find Earth-sized planets orbiting other stars? Do you want to take that?
Yes, there are several instruments right now. For example, in the 1.5 meter telescope, there was an instrument that was basically using the technique of radial velocities to detect these planets. It's Chiron. Probably what you really need, it's a very focused instrument to do this. And I think right now, for example, for radial velocity, there is none. However, they're now using all of these small telescopes to do transits. That it's a photometric technique in order that you basically see how the planet occults the stars, so the stars gets dimmer, less bright. And that's something, for example, that some small telescopes can do at CTIO.
It's a good point too, because we talked about the Blanco Telescope at CTIO, which is this sort of the giant dome that you were describing. But there are many telescopes at CTIO, different sizes, and I think there's even a fleet of small telescopes. I don't know if they're looking for Earth-sized planets, but they're looking for exoplanets.
Yeah. It's the thing about not only having the telescope, but also you need an instrument that can do the stuff. So for radial velocities, what you need, it's a really stable instrument that doesn't move much, so you can make these measurements that are very precise. When you do transits, it's a little bit easier. However, for example, the atmosphere plays a huge role, and that's why, for example, TESS exists, that it's a very dedicated space telescope just to search for these transits and to search for, hopefully, Earth-sized planets around the closest stars to us.
Very cool. All right. Well, if we don't have any other questions, and I don't see any other popping up, thanks again for joining us. And thank you everyone out there who tuned into our Facebook Live and today, especially our Big Astronomy YouTube and Facebook streams. And we'll hope to see you again soon.